Now we're going to combine arithmetic and geometric sequences. They're just two different types of sequences, one based more on linear addition and subtraction, and one more like an exponential where you're multiplying. So first of all, we got the arithmetic. And an arithmetic sequence is a sequence that the difference between any two consecutive terms is constant. What I would add to that, we add or subtract to get to the next term. So if we start with the first term, a sub 1, we call d the common difference of the sequence. So the nth term of an arithmetic sequence with a common difference d, you could take any term and subtract the term before it. So an explicit formula for the arithmetic for any nth term is the first term plus the difference times n minus 1. The recursive formula, remember that's the one that's dependent on a previous term, is the previous term plus that difference. And again, for this one, the n has to be greater than or equal to 2. The second type is a geometric. A geometric sequence is a sequence that the quotient, okay, so we're multiplying or dividing. A quotient between any two consecutive terms is constant. So we multiply or divide to get to the next term. So if we have the first term a1, we're going to use r to represent the common ratio. And to find that ratio, we would take any term and divide it by the term before it. So the explicit formula for a geometric is the nth term would be the first term times r to the n minus 1. Notice how that looks like an exponential. You have your initial value in the front, and you have that ratio or the rate at which it's growing to the exponent. Recursive formula is the ratio times the term before it. But again, we have to start with a term greater than or equal to 2. You have to have at least the first term. So again, notice the difference between arithmetic and geometric. The arithmetic explicit formula is a linear equation. Okay, it's a linear equation, whereas the geometric is an exponential. So let's look at some examples. So we want to write an explicit formula for the nth term of each sequence, which means we first have to determine, is it a pattern that is either linear, you're adding or subtracting the same number every time, or is it exponential, where you're multiplying or dividing by the same number every time? So if we focus on A, we seem to be subtracting 5 every time. So that means we have a common difference of -5. You could take any term, subtract the number before it, 60 minus 65, -5. So our explicit formula is going to be the initial value of 75. That's where we're starting, minus that difference of 5 times n minus 1. So what does that mean if we were to reduce this? 75, distribute that -5, we get a -5n plus 5. So we would get an 80 minus 5n. So that would be our nth term. So notice that common difference is like our slope, right? It is decreasing by 5 every single time. If it was increasing, then it would be a +5. Now let's look at B. How is B changing every time? Well, we don't seem to be adding or subtracting, right? We're going from a 2 down to a 1/3 to a 1/18 to a 1/08. So if you can't see how it's getting from one term to the next, remember to find the ratio. We could take any term and divide by the term before it. So let's say if we took the 1/3 and divided by the 2, that would give us a 1/6 as our common ratio. And we can double check it. From here to here, we multiply by a 1/6. Here to here, 1/3 times 1/6 gives us a 1/18. And an 18 times 6 gives us a 108. So we are multiplying by 1/6 every single time. Our recursive formula is our first term, 2, times that common ratio of 1/6 to the power of n minus 1. And that's as far as we can go. That's our formula. Now let's take a look at C. This one's a little bit different. Notice it alternates signs. If it alternates signs, then it's not going to be arithmetic. Now, that doesn't mean it can't go from positive terms to negative or negative to positive. You can add or subtract where it eventually changes signs. But notice it goes from a negative 1/2, positive 3/4, negative 5/6, positive 7/8. They're alternating. It could be geometric. We would have to look and see. So we can choose any term, like a negative 5/6. And let's divide it by the term before it, 3/4. We can write it out the old-fashioned way if that helps, times 4/3. And that would give us 20/18, which reduces to 10/9. But in order for that to be a common ratio, that has to be the same ratio between any two consecutive terms. So let's try it again using 7/8 and 5/6. And that reduces to a negative 21/20. Those ratios are not the same. So different ratios, not geometric. But that doesn't mean we can't figure out what this formula is. So we do know that there's an alternating sign. So remember before when we had that alternating sign where the first guy was negative, we just have a -1 to the n. Just multiplying by that every single time will flip-flop the signs for us. Now we got to figure out what kind of pattern is going on. Well, even though the whole piece isn't arithmetic, let's look at the numerators and the denominators separately. 1, 3, 5, 7. What's happening with those numbers? Notice they're all odd, which in itself is arithmetic. You're adding 2 every time to the top. So we can write the top of that fraction as an arithmetic. The first term is 1. Again, remember that -1 in the front. We'll deal with the flipping of the sign. So we're only looking at the numerator itself. So our first term is 1. We are increasing by a difference of 2 every single time times n minus 1. So the top is arithmetic. Now let's take a look at the bottom. 2, 4, 6, 8. Again, it's increasing by 2 every single time we add 2, add 2, add 2. So the bottom is also arithmetic. It just starts with a different number. So the bottom starts with 2. It is still increasing by 2 every time. That's our common difference times n minus 1. So now we can actually simplify what's inside the brackets. We still have -1 to the n on the outside. We get 1. Distribute the 2, we get 2n minus 2 on top, and then 2 plus 2n minus 2 in the denominator. -1 to the n with 2n minus 1 on top divided by 2n in the denominator. That in itself is an explicit formula, but we can keep simplifying it. -1 to the n. If we reduce those two, we would get 1 minus 1 over 2n. We can even distribute that -1 to the n if we wanted to. That would give us -1 to the n minus -1 to the n over 2n, or vice versa. All of those work. This one, this one, this one, all of them are considered explicit formulas for a sub n.